So some ways to select a simple random sample. So many of you have probably experienced some of these ways by teachers over the years and so on, where they might put all the names in a hat and draw out a certain number of names out. Okay, so as long as everybody's name is in there once, they're all on the same size piece of paper, and we mix them all up in the hat, everybody has the same chance of being chosen. A more sophisticated way would be assign each individual in the population a number and use a random number generator on a calculator or a computer to randomly select the individuals that will be measured. So we have a couple different ways, different forms of technology that we can use to do that. So if we're going to use the calculator, let's say we have a class that has 30 students and we want to use the random integer generator to randomly select 5 students. So this first bullet here, it's really important that you pay attention to what is written here. That this first step you will never have to do again. So in coming back to this technology box for homework and so on, you would just start with using the TI-84 instead of this first bullet. But before you use the random integer generator for the first time, you're going to take the last 4 digits of your cell phone number, because that's probably different for all of you. You're going to type them on your calculator, and then you're going to type the following sequence of key punches. This just puts in a random seed number into each of your calculators so that they're kind of all starting in different places in this big random digit table that's a built-in feature to your calculator. Once you do this once, you never need to do this step again. Okay, so in using the TI-84, it does have quite a few different random number generators built into it. So if you were to push your math button and arrow over 3 times to get to the probability menu, and then choose button 5, here where it says random integer generator, this function will require 3 inputs: a beginning integer, an ending integer, and the number of random integers in that interval you want generated. So the beginning and ending numbers would be if you were to assign everybody in the population a number, so from 1 to cap n. But then how many you want generated depends on the type of sampling that you're doing. So if you are sampling without replacement, that means you're going to pick something from the population and it does not get put back before you pick another, which is the typical type of sampling that we do. We typically number the objects in the population from 1 to cap n, and then we're going to use random integer 1, cap n, 2 times little n. And that 2 times little n just means it's going to basically generate twice as many numbers as what we may need, but there's some chance that it's going to produce the same number in there, and we don't want that. So we're going to take the first n unique integers in that list of numbers. If you're sampling with replacement, so if it's okay to have, we're going to pick something and put it back before we draw another thing, then we're going to just use 1, cap n, little n. We're just going to ask for how many digits we want, and if there's a repeated value in there, that's okay, because in this case it was sampling with replacement. An example of that would be like if we want to mimic rolling a die with the numbers 1 through 6. Okay, every time you roll the die, it still has the numbers 1 through 6. So it's not like you roll a 2 and then it disappears from the die before you roll it again. So that would be an example of sampling with replacement. So in this particular example, we're sampling without replacement. So we're choosing people for a study, so it doesn't matter how great of a person you are, we don't want you in our study more than once. Cap n is 30, because that was the total number of students in the population, and lowercase n, little n, was 5, because that was the sample size of students we would want. So we would enter 1, 30, 10 on this screen. Since we want 5 without replacement, that means we would end up in that last slot, we would double 5, which is 10. So we would enter random integer 1, 30, 10. Okay, that's going to tell the calculator to randomly pick a number between 1 and 30, 1 and 30 included, record the number, put it back, take another number between 1 and 30, record it, put it back, and so on until we have a list of 10 numbers. So on the screen here, when I did this for the video, you can see I got the numbers 28, 28, 5, 16, 13, and so on. And you can use your arrow keys to scroll to see more numbers. Now, if you were to do this on your calculator, you would not see these same numbers because they are randomly generated. So it would just be like if you and I each had a hat with the numbers 1 through 30. If I randomly pick out 5 numbers, I'm not going to get the same numbers as you do when you randomly pick out 5 numbers. In the course, we're also going to be using a website called www.random.org, which also will give us, and it has the option to do with replacement or without replacement to generate random numbers there as well. So example 1.2.1 says choosing a simple random sample. So we're asked to describe how to take a simple random sample from a classroom of students. So we could, like I have a roster, so I could use my roster and assign each student a number. And then use a random number generator. And pick the number of students you want. So the problem didn't really specify how big of a sample we wanted, but if it was like the one in the box, if we were to want 5 students from a classroom of, let's say, 30, again, we could use that random integer 1, 30, 10, and then just take the first 5 unique numbers. So in the example up above here, we would have used students numbered 28, 29, 5, 16, and 13 on the roster. It just so happens in these first 5 that we didn't have any repeated values.